One. Hello, everyone. This is Clint Vrazel with the OU Text Analytics CS 5970 class for the Data Science Analytics Masters of Science program. I'm going to be interviewing today data scientist Frank Evans. Very excited to introduce you to him and he to you. Frank and I have a sort of unique, if not uncommon history in that we both were comedian turned data scientists. We should have met each other many times, but actually didn't meet until I got into software development. Met him at the Tulsa Tech Fest, where he gave a very interesting talk about his different approaches, some interesting projects he's done, like on using data science to solve the gerrymandering problem, among many others that include text analytics. I really appreciate the way Frank's has a passion for teaching, the way he approaches the material. He's active in the local lightning talks and big data groups. So you can see him on any sort of stage, teaching any sort of person on any sort of topic. Like my definition of like a, polyglot, like polymath. Let's just approach it all. The whole fun thing about data science is to play in all sorts of different backyards. You don't have to get tied to one subject domain. So I'm very excited to share Frank with you with that. He's got a background in science, but then also he got an MBA and then moved into data science work. You've worked for Sonic and you work now for Exaptive. Am I saying that right?
That's correct. You are indeed.
And you are involved in several big data, whatnot, meetups. And you can talk a little bit more about that. But hello. So first question, how did you get into data science?
You kind of set me up a little bit on this particular one. When I was working at Sonic, I started out. I came sort of through science, through business, through MBA. And very much wanted to get sort of into the business analytics, financial analysis, I thought at the time, and sort of general operations analytics and business analytics from there. That's what I did at Sonic when I first started my career at Sonic. And then as I started to get into it, I ended up getting assigned, kind of because I was low man on the totem pole, ended up getting assigned to some kind of QA work with our business intelligence developers around helping design and helping make sure that the QA of design of some of BI reports were coming through correctly. I started to kind of get this sense that there was a massive amount of disconnect between understanding the sort of technical side of the data world from the little more kind of analytics side, what would effectively become the scientific side, but more the analytics side from the business world. This was back in 2010, still a year and a half before the data science term was even going to be coined. But like a ton of other people saw that these two groups of people spend tons of time and money on projects, and the ability to be able to communicate between the two and kind of bridge that gap. There is a career's worth of value in that, and I want to go see if I can shade that way and explore it. And so I started shading that way, and then as anything, shaded way over to the other side, and ended up really falling in love with some of the technical implementation, some of the engineering aspects, and really just dove headfirst all the way into that. And that's pretty much been the running theme of my career. So.
Great. And that's a tough direction to go, is from the business. But so you already had the science before that, but you could go from business and ask those good questions. So everything has a point, everything has a business case. You're ready to make that pitch along with all the technical work that I know you do. So can you talk about some of the tools that you used or created, just briefly, in your career?
Yeah, sure. So when I worked I've worked primarily in this type of role for two main companies. For Sonic Corporate, which was is a Fortune 1000 company, so it's going to be more toward the large end of the spectrum. It's not going to be one of the kind of massive companies that has a lot of needs to solve things at a large enterprise scale. Versus the company I work for now, Exaptive, is kind of a mid-stage startup. So we're not brand new. We're not 4 people in a garage. But when I joined the company, I was employee number 9 at the company. So we kind of were, we were sort of MacBooks and card tables when we first started, when I first started with the company. And so having sort of seen both ends of that particular spectrum, within that, I very much leaned more personal. I think when I was with Sonic, leaned more toward using technical tools more directly. So I came into the business analytics world wanting, like anybody else, to get my full black belt, like Excel Ninja credentials. And after I kind of was sort of medium grade, good at that type of thing, got the opportunity to work with a few tech tools that were kind of like a data processing query language sort of thing. And I have leaned very heavily toward doing that. I started working in tools-wise. I started working in R not too long after that. As I got more and more into the engineering side, I've gravitated a lot of the R stuff a little bit more toward Python. I use JavaScript now and again, just enough to kind of glue stuff together and hope and it doesn't really fall apart terribly often. And then I end up using, because of sort of my nature, I end up doing a lot of actually the data engineering sort of end of the data science spectrum. And so I end up working with a lot of different database technologies and working with them. So SQL, I work with a couple of graph.
MongoDB?
I work a little bit with Mongo. Mongo is really good at having you work with it using existing libraries. Mm-hmm. And so you work with Mongo, when you work with Mongo, you rarely are working with it like a database. You're usually working with it like it is a memory object, and then it handles the database interaction for you. It's kind of one of the great things about Mongo, but the downside is
I interrupted about you're getting into graph databases. Yeah, so mention some of those.
And I work, so my kind of specialty has primarily been around natural language processing and around graph structure, so working with graph structures of different kinds. And so I work with, there aren't really, for the most part, there aren't really like natural language processing databases, Elasticsearch to a very, very small extent. But they're more about solving engineering problems with the in the NLP space. But in the graph world, because the structure is so dramatically different, end up working with a couple of different sort of graph processing tools around there. But primarily, to give you a quick version, I work in Python with most of the stuff that I write, and use like Python modules and that sort of thing to do most of the sort of data engineering I do on a daily basis.
So graph-based databases I'm familiar with, and I use some OrientDB, and I've read up on Neo4j, which is similar. And then there's also, I know Spark has like a GraphX to do like large-scale graph analytics, a lot of built-in stuff. Now you say you use Python. Like, have you? I also see that you're familiar with, and you use Apache Spark. So how fluent? How much have you had to rely on Spark to really tackle the large scale problems?
As I got so less and less over the course of the past probably 2 years, as I transitioned away from Sonic, which actually uses Spark to a pretty strong degree, and transitioned into Exaptive. We were using Spark far less. We did a couple of projects involved I worked with it, including one of them was an NLP project using Spark, which I'm happy to sort of talk through the high levels of. Or,
do.
Oh yeah, for sure. But that project is about 2 years 2 years ago, and I've used Spark little bits here and there for a few things, but largely not to a great degree. So the project that I worked with Spark and with NLP simultaneously was a project actually with your university with OU. It was through the library sciences group, but it was very specific to a project that a PhD researcher in political science was working on. She wanted to be able to understand some congressional hearing transcripts at a very high granularity level without having to actually read all of them. She had transcripts going all the way back to the beginning of the Clinton administration, so the early 1990s. And they were all congressional hearing transcripts specific to committees that would have something to do with international relations. And there were just shy of 20,000 of them. Hope you're sitting down. Congress loves to talk. So tons of these extraordinarily dry, difficult to find stuff. Now you can easily, she could do like searching, that type of thing, but she really wanted to understand was, how can I understand the landscapes and understand patterns that have existed, from the time of 1992 all the way up to about 2015 was where we were at the time. 2015, 2016 was the most recent available at the time. And she wanted to understand the differences sort of in international politics for a few different very pointed questions. We used Spark in that case to build a number of different topic models. We used LDA, latent Dirichlet allocation, as our mechanism for building those topic models. But these topic models, we built a number of them and then built an application, which is what our company does, is we build interactive data applications. We built an application that allowed her to explore, to actively curate those different topic models and to sort of understand the landscape that would happen from two perspectives. One, from looking at different granularity levels, so looking at if we were to group these into maybe 4 or 8 topics with a pretty high level, what does that look like versus how does that relate as it gets higher and higher granularity down to maybe 32 or 64 different topics.
Right. Can you learn anything from increasing the number of clusters?
Right.
So
and then because it was...
Go ahead.
Oh, sorry. I was going to say, the other side of it that even feed into your question is because it was congressional hearing transcripts, very metadata rich. We knew who was talking. We knew whether, we knew at the time, like, exactly what committee it came from. We knew who was involved with it. We knew who the witnesses were. And we knew exactly when it happened. So we had this great, time series linearity aspect to it. And so it wanted to be able to explore how do those topics change throughout time and throughout sort of different political eras, if you will.
That is, even coming up with classifying what political era are we in, that's a fun thing. That's another question.
Yeah.
So what were the NLP challenges? I know you said who was talking or what they were, the agenda, but what were some of the entity recognition, some of the parsing limitize, what were some of the NLP challenges just to sort of, pre-process and get that into a state capable of being modeled?
For sure. So it's sort of fitting in a small way that I work in NLP and in graph structures very commonly. Because there's one thing they have in common that I don't think really gets thought of all that much, and that is they are sort of big data in the way that is not the kind of big data that you usually hear about. Usually big data is what I would think of as heavy or deep. There's a ton of it. And just dealing with storing it all and getting to any piece of it, that's really what you have to deal with. And that's not really the case usually with text data and with graph structure data. I'll lean more on the text side. Text data is pretty efficiently stored. Even with a pretty large amount of what you would think of as text data, more than you could read in the next several centuries, you can all fit on all the text, all the raw text itself can easily fit on a thumb drive that you can get for $20 10 times over. And so what the challenges that come particularly with text data, but they end up really reinforcing themselves in graph structure and these linked entity analyses, is they are computationally intensive. And so being able to solve those computationally intensive problems in an intelligent way makes a massive, massive difference. And Spark is really good at doing that. It's really good at parallelizing things, and it's really good at understanding that you can take what is relatively a small amount of data but need to do a very large amount of processing against it in order to be able to do something useful with it. That particular one, we didn't do anything terribly. We really, a lot of our sort of invention in that world was around building the topic models in ways where we weren't really trying to reinvent a new wheel there. We were really trying to reinvent a new way of interacting with topic models, and how do you learn, how do you get something useful out of them other than just, the most common words up in a word cloud or something. Like how could we do something that was more effective with them. And so in that world, it was very much about representing pretty fair metrics, representing pretty fair things. And it was really on that particular project, and with a number of them, it's about being able to connect what you can learn from the text data in the context of a pretty rich metadata environment. So having rich metadata around text data gets you in the NLP world that I've worked in. Having rich metadata to associate with it actually is where you can start to see trends, patterns. Is really where you can start to solve interesting problems in the text world.
Yeah, great. And that's huge. So it's not necessarily like the size there, but the connections, the context, and then the ultimate user who's not as computer savvy as you guys, looking for some way to interact with it and view it to get understanding. So you helped discover that. Like they helped ask the questions and you helped find the answer. So you kind of met them. So it's nobody could have done alone. You had to have that collaboration.
Right. Well, yeah. I said that's a pretty good way of putting it. Yeah, it's people who didn't have. We were working with this particular researcher who didn't have. Of course, didn't have the sort of technical background that we specifically had, but we didn't have the political science background that she had. And so we would find, we would put together these sort of associations and be like, okay, that looks pretty good. It looks clean and it's right. QA-wise, like all the pieces are working. And then she would be able to look at it, and her domain knowledge, of course, in this area is so much higher, would instantly start, oh, really? Is this like these two things are like moving in this sort of same pattern? And she would find really interesting things from that perspective. So having that very tight feedback loop where we could try things out from a technical perspective, from a modeling perspective, from a science perspective, and then she could come in, bring the domain knowledge and start to figure out, is that getting her some sort of value where she could go find, hey, let me go find those transcripts, and she'd go kind of hot read through a few of them and be like, yeah, that's easily consistent. And that's the type of thing that, me doing a Google style search for keywords was not really going to find. The fact that like the way this subject was talked about like materially changed, between late 90s and obviously the biggest change, we would see these just like crazy changes and all kinds of stuff that happened in 2003, and then you go and look and be like, oh, they all seem to like the whole world of congressional international relations hearings seemed to really change when the Iraq War started in 2003, and then seriously the word oil showed up more often. I mean, all kinds of fun things that could start to answer interesting questions.
Great. What's just a simple vocabulary change or a colloquialism versus what's a real international, political, socioeconomic change?
Right.
Did you discover a nickname for Scooter Libby, or did you discover a code name for Deep Throat? What's the
that's right.
association? Great. That's a great sort of lesson in what can come out of this and how that goes back and forth. Now, a lot of us students here, and actually in my professional experience as well, we sometimes find that we're like, one of the few data scientists on a project, or the only one, or wearing a couple hats. And so we're going to get thrown at a big project, and we're going to fail fast. Things are going to sink. Can you talk about maybe something that a project, and I don't know if you have any failures, I don't know if you live a golden life free of stress and peril, but can you talk about a project that failed or nearly failed, or some principles you keep in mind when you are, when you're not seeing what you need to see, what can get you unstuck, or what can you just, what can you just swallow and learn, for the next time?
Right. I absolutely can talk about one. So I can't give you a ton of the specifics on it because I think there's ongoing research outside of us in it. I don't want to make it where it could be figured out what it was. But we worked with we worked with a group. We worked with someone who was interested in understanding sort of the feasibility and the explorability around creating a product that would effectively would do like prediction against certain types of international markets based on sort of publicly available data. So think stock market. It wasn't literally stock market. It was more around like pricing markets for logistics services, but things that were subject to change on a daily basis due to conditions in the market. But because of its world, we're contracted anywhere, we're on like a minimum 30-day contracts, and quite often, several 3, 6, and 12 months in advance. And so being able to figure out, hey, what is this market going to be doing 6 months down the road, meant I could buy a contract today and then sell it, 6 months later and make a big profit, if I knew whether to short or long that market. And there were, dozens of these sub-markets. And so a lot of potential value in that world. And based on a number of different sort of publicly available and conglomerated data sources. And one of the sort of big failures that we had there was we had, as we were modeling some of this stuff, we sort of modeled in a very quick way to understand, how we wanted to be able to interact with these modules, how we wanted to be able to interact with this data, how we wanted to communicate it. And then we spent a lot of time working on how do we want to communicate it, and how does the interaction work, and how does the UI work, and how does somebody log in, and how does, and how do we, make sure that we're communicating like these predictions in a very fair way. And what we really did not do a sufficient amount of due diligence on in that particular project was making sure that, one of the things we're trying to do that we sort of lost sight of was we were trying to prove that the science was legit, that you literally could, that we literally could create enough value that someone would want to purchase this product and use it to do this type of trading. And a lot of people really believed that this was something that we could do, and we really got to the point where we skated by on making sure that we had ironclad science behind us so that we could get the technology up where they could kind of come into their own simultaneously. And we ended up with a pretty good application that could communicate predictions in a pretty fair way. It was really ready to go into a public beta, and at the same time had more or less, once we started doing due diligence with people who understood the statistics and the science extraordinarily well to sort of check our work, that we were effectively no better than not materially better than random at being able to do the thing. So didn't have the science where it needed to be, or weren't able to positively find a pattern in a way that we could construct that pattern. And that was a pretty big lesson for me to learn. I mean, I was the lead on that particular project. That was not our company learned this and I remember the story. No, I remember the story, very firsthand. And that's the thing I sort of learned from that is it is super easy to get ahead of yourself, and it's super easy to solve the more interesting problems rather than the necessary ones. And
the interesting problems and the necessary problems. I like that. To full speed ahead with the part that you like and are challenged. Like, what's a new way to share this? We all talked about interaction. This is great, but what is it? So no better than chance. That's fantastic. I recently had a model. It's like 55% accurate. Wait a minute. There are only 2 classes here.
Right. Yeah.
I'm a weighted coin flip here.
Yep.
So what have I?
And given the cardinality of your prior, you may not even do that.
Yeah. 4 times. Well, that's been fantastic. Thank you for sharing like your ups and your downs. I think everyone's gonna take something away. And where can they see you? I know that you work at Exaptive. You can talk briefly about your in the last 1 minute, talk about your big data meetups and where you like to share what you know and learn from others.
Yeah, indeed. So I usually, as and you kind of teased a version of this from the very beginning from us meeting in this sort of comedy world, or knowing of each other sort of in the comedy world. Didn't materially meet until later, but knowing sort of reputationally in the comedy world. This is going to shock all of you guys. There's not a ton of people in sort of the data science or larger programming world that are known for being like extroverted characteristically. So I get invited to speak a bunch of different places. Not that I'm the smartest person in the room. Usually I'm bottom third at best. But I usually am like, top 5% most extroverted. And so because of that, when, I get invited to stand up and be the loud one at the front of the room, which I do love doing. So I speak all over the place. I'm a co-organizer to a small extent with the Big Data in Oklahoma City meetup, which is on Meetup. I also, through our company, Exaptive, sponsors the Data Plus Creativity meetup, which is very interesting. We do a bunch of different things. It's kind of a bringing like a data analysis and sort of visualization art and that sort of thing, kind of bringing creativity and figuring out things from an analytic perspective, kind of bringing things together in various sort of areas on that spectrum, and we do some neat stuff there. Bring some really interesting people in there. So that's on Meetup as well. Check that out. Via the name that's on the screen or whatever with like LinkedIn or something. I sort of speak, kind of float around to different places and try to attend as many as I can that I'm not speaking as well, because there's a lot of really cool stuff going on in this in the Oklahoma City community, and this is a really cool time for the tech community here in Oklahoma City. So I'm really happy to be a part of it.
Fantastic. And I know that there are a lot of local students that are going to get a lot out of that. I know I have. And again, because this is such a big place. I know that as students here, we are all at like the edge. We learn up to the edge of research, and then if you want to know how it's implied or implemented, or what to do next, who are the companies, all that stuff, who are the players. Great. Well, thank you for your time, Frank. Pleasure as always. I hope to see you in real life real soon. And thank you on behalf of OU Text Analytics.
Absolutely. Yeah. Thank you.